In this video, we will be analyzing heat transfer across fins and extended surfaces. First, we'll begin by analyzing a single pin fin. It has a simple geometry, which involves an enclosure imitating a duct of air and cylindrical pin attached to the base of one of the sides, as in the video. Moving on to the meshing part, and due to the fin's simple geometry, which doesn't involve any complex shapes or edges, the mesh of this simple fin has a low element count and an acceptable mesh quality. We move on to naming the parts. Start with the base, which consists of the fin's base and the enclosure's base, which will later on imitate the heat source. Then we name the air inlet and outlet. After that, the sides of the duct. And finally, we name the surface of the fin. As for the solver, we will be using Fluent. We'll start by enabling the energy equation, and then by setting the flow to laminar, since we have a low velocity of 2.5 meters per second and a small diameter. And then we will identify the air as being an incompressible gas. Here we can see different surfaces labeled. The air base will have a temperature of 1000 Kelvin, so will the fin base. As for the inlet, we will specify the velocity of 2.5 and a temperature of 300 Kelvin. It's important to set or to check that the surface of the fin is set to have a coupled wall treatment, and that is to enable the solver to take care of everything that takes place on the interface between the surface of the fin and the surrounding air. We see here that the calculation is complete and the solution has converged, so we'll revert to analyzing the obtained data. In the contours of the temperature across the fin, we notice a very nice colorful decreasing temperature gradient from the bottom of the base up to the tip of the fin. Here we see the air moving in and the heat rising up. We notice a higher temperature of 700 at the bottom and lower temperature of 300 at the tip. Here we are measuring or taking the temperature distribution curve along the axis of the fin. And finally, we want to measure or obtain the heat rate transferred from the fin to the surrounding air. In conclusion, I'd like to end this video with an image of two curves, one corresponding to the temperature distribution of a single pin fin as by a numerical solution, just like the one we saw in this video, and the other one is a temperature distribution curve as by an analytical solution. Thank you for watching this video, and don't miss part 2, which talks about arrays of pin fins.